Okay, so we already started our lesson, sorry. I should have started recording earlier. All right, so let's do it my method. All right, so I've got x times x is x squared. Then I have negative 3 times negative 3 is positive 9. And then I have rainbows and checks. Negative 3x and negative 3x makes negative 6x. I know my y-intercept must be 0, 9, because this number right here is my constant, and that tells me it's my y-intercept. I know that I have 2 x-intercepts. Actually, it's 1. It's called a double root, okay? Because it's a root of the function, but it's a double root because we only have one of them. So at x equals 3, that's the only time it's going to touch the x-axis. So a double root actually skims the x-axis, which means this also must be my axis of symmetry. So my axis of symmetry is also at x equals 3. And then I know I've got symmetry here as well. If this is 1, 2, 3 away from the x-axis, 1, 2, 3 away is another point. And that's all I need. Not very accurate, but that's fine. What is the difference between that graph and an absolute value graph? No. It doesn't even, you know what we're going to find out, Aaron? That it doesn't even have to have real zeros. It can have imaginary zeros. Right? Jay, let's not have a negative mindset. Good. Good, good, good. I'm glad to hear it. Because I'm going to show you a way that's going to make sense. And I'm going to show you all different types of things. You're not going to have to memorize anything. We're going to make sense out of all of it. So here is a function with only 1 0, right? Here's a function with only 1 0. Here's a quadratic function with no zeros. It doesn't ever cross the x-axis. It has imaginary zeros. And we're going to be able to find them. Yes, King? You could plotting points using a table, yes. You could use a table to plot more points. All you'd have to do is say, okay, and you could actually use a table because you want to make it nice and pretty and spend more time, Kane. I would totally be happy with that. Check this out. This is how you guide yourself. If I know that here, at the axis symmetry and the vertex, we're at 1, 2, 3, then the next point I would try and plot would be 4. I'd put 4 into the equation, and then I would get y. Or maybe I would try 2, because I know that it's symmetric. But actually, I wouldn't need to do 2, because these two would be the same. Because no matter what 4 is, it's going to be the same, and whatever 2 is. So I'd actually just go in one direction, and then just do symmetrically. Oh, yeah. Right? Makes sense? Okay, let's move on. Why don't you guys do one? Yay. Why don't you do one? Okay, so let's do this one together. So I have my first, which is my x times my x, which is x squared. Then I have my last, 1 times negative 1 is negative 1. And then I have my rainbows, positive x, and negative x makes no x. This is actually called something. Does anybody remember? When I have 2 binomials and they have opposite signs and the same constant, do you remember what that's called from Algebra 1? It is called the difference of 2 squares. It's a special product. And what that means is that you've got a square on this side, right? I've got x squared. You've got a square on this side. 1 is actually a square, right? 1 squared is 1. That's a square. And we have the difference, but they have different signs. So it's the difference of 2 squares. And what happens with the difference of 2 squares is the middle falls apart, right? And we don't have a middle. So what happens with the difference of 2 squares, since it has no middle, remember we talked about if there's a middle term, that's what shifts it this way. right? There is no middle term, so the only thing that's going to happen is the parent graph is going to start at, this would be a parent graph right here. And what's going to happen is all it's going to do is it's going to shift down one. That's it. That's it. I'm going to rewrite this, though, a little bit better. So I've got x squared minus 1. Here's my y-intercept, negative 1. I've got two different zeros. I've got a 0 at x equals negative 1, and I've got a 0 at x equals 1. My axis of symmetry is actually the y-intercept still. So my axis of symmetry is x equals 0. My y-intercept is 0, negative 1, and that's really all I need. I think I'm ready to move on. Yes, King?
So I got the photograph.
Let's see what you have. But negative 2x would actually not look like that. Okay? That's fine. I'm going to do this one really, really quick. So I've got x times x is x squared. 1 times 3 is 3. 1x and 3x makes 4x. Pretty quick, right? I know my y-intercept is 0, 3 because of this. Go ahead and plot that. 0, 3. My zeros are at x equals negative 1 and x equals negative 3. The reason is because I could set this up to 0. When is x 0? Well, it's at negative 1. That's why we call them zeros. Okay? Then I'm going to plot my axis. Let's plot my zeros. I didn't plot them. Negative 1 and negative 3. 2, 3. So my axis of symmetry is right in between them, where x equals negative 2. And then I know I've got symmetry right here. If this is 2 away, then I can go 2 more away. And then we're done. Thumbs up, thumbs down. How are we doing on this so far? Okay, let's go the other way. All right, pencils down. I'm going to go backwards now. So we went forward, right? Now I'm going to factor this to get my zeros. I already have one piece of information. What's my piece of information that I already have? The constant, my y-intercept. So I have my y-intercept is right here. It's at 0, 10. So I can already graph that. This is positive x squared, which tells me it's going to be positive. It's going to be going up like that. This also tells me it's got a minimum. But we'll talk more about that next week. Okay, so I got to factor it. Well, I already know I'm going to go backwards. I know the x squared belongs here. You know what? I'm not going to even do that. We're going to expand it. So I have x squared. This is the first time I've taught it this way, so bear with me. I have a 10. 7x gets broken up into 2 numbers, just like I did with this one, right? We've got 2 different numbers. They're not numbers, terms, 2 different terms. So what could I break 7x into? Splitting it up in 2. That still adds up to 7, but are factors of 10. 5 and 2? Love it. So this would be 5x plus 2x. Does that make sense? Because 5x's plus 2x's make 7x's. But I'm going to want to use the commutative property and switch these two. I want to switch these two. Can anybody tell me why? Actually, I don't think I have to. I don't have to. As long as they have factors here and factors here, we can do it. I could, does it matter which way? I could switch them the other way as well. It would work both ways. Okay, so check this out. So I'm going to say this, I'm going to group this one, and then I'm going to group this one. So if I just look at these two, they both have an x. So I'm going to factor out an x, and I'm left with x plus 5. Then over here, both of these have a 2. When I factor out a 2, I get an x plus 5. Do you notice that they both have x plus 5 in common? So I'm going to factor out an x plus 5 from both of these terms. See how this is one term right here being multiplied, and this is another term being multiplied? I'm going to factor out the x plus 5. So that's like saying it's gone now. Factor out the x plus 5, and what am I left with? I'm left with x plus 2. Okay, I'm going to do a couple of them for you. I'm going to get rid of this. If you have another method, you can go ahead and use it. I'm not going to make you do mine. So we have, that's the way I'm going to show it. Okay? So I have x plus 5. I have a 0 at negative 5. And I have a 0 at negative 2. Negative 2, 3, 4, 5. It means I have an axis of symmetry right in between those. Uh-oh. But there is nothing right in between them. Sure there is. It's right in between. It's a half. Right? It doesn't have to be on one of these lattice points. So negative 1, 2, 3.5. That's totally okay. And I still have symmetry. So I've got 1, 2, 3 and a half. Half, 1, 2, 3. So that messy half is not that big of a deal. And there it is. All right, I'm going to do one more, and then I'm going to have you guys do one. Okay? All righty. So I've got my x squared, and I've got my negative 6. And how am I going to break up x so that it has factors of negative 6? Think of two numbers that make up negative 6 when you multiply them together. 3 and 2. 3 and 2 make 6, right? So how could I make 3 and 2 3x and 2x? When I add them together, how could I make them positive x? One of them's got to be negative. One of them's got to be positive. Positive 3x and negative 2x makes positive x. Alrighty? So now I'm going to use my factor by grouping. So here's my first one. Here's my second one. This one's going to be a little bit more tricky, but that's okay. I've got an x here that I can factor out, and I would be left with x plus 3. Then over here, I have a negative 2 I could factor out of both of these. Negative 2, oops, needs to be blue. If I factor out a negative 2, I'm left with an x. Negative 2 out of negative 6 makes positive 3. And you know you're doing it right because these two should match. Yes?
X plus 3x and the other, those are two different.
Yes. We're looking at them. We're grouping this one.
Yeah, I'll look at it
And this
one. All one, like, maybe.
Yeah. We're grouping it. We're splitting them up and treating them separately. So now I've got two. Now they're two factors instead of 4 terms. Now we only have 2 terms. So I'm going to factor out an x plus 3. And just like I told you, as soon as I factor it out, it's gone. I'm left with x minus 2. So we already knew what our y-intercept was because it's right here. 0, negative 6. 1, 2, 3, 4, 5, 6. Then I know I have 2 zeros. They're right here. X equals negative 3 and x equals 2. Negative 3, positive 2. I have an axis of symmetry in between them. So I'm just going to count with my fingers. Look, it's another half one. So my axis of symmetry is actually at -1/2. Or I could put 0.5, doesn't matter. Or 5/10. And then I also have symmetry here. And I can graph it. So all you need is your zeros, your y-intercept, and then the other point on the other side of the x-axis from your y-intercept. You guys ready to do one on your own? No? Well, try. Get as far as you can, and then I'll come back and I'll do it with you. All right, try this one. So we're going to switch over to homework problems, which I have in the back of this presentation. So let's go. I think you guys can do the foiling. Let's go to the back, which I think is right here. No. Let's start here. You guys have the graphing? You just want to practice the factor by grouping? Okay, let's just practice the factor by grouping. So we'll start with this one. I got it right here in my hand. So you can always check your answer by multiplying. First you factor by grouping, and then you can go back and multiply the two binomials, and if you get the same trinomial, then you know you did it correctly. So go ahead and factor that. It doesn't matter if it's V. Okay, so Hope just said, can I just do this? Because guys, I personally don't need to factor by grouping. I can do it in my head. I know that this is V and V, and I know this is 6 times 4, and I know 6 and 4 make 10. So I check my work by doing rainbows and checks. 6V and 4V, I put X. 6V and 4V make 10V, positive, and V, I know V times V makes V squared, and I know 6 times 4 makes 24, and that's what I mean by checking your work. If you can factor that quick and check your work, you're done, okay? But I'm going to do it I'm going to do the factor by grouping way. Hold on, Nate. So, hold on. Okay, so I'm going to leave it there. I'm going to actually make another slide, a duplicate slide, and I'm going to do it the other way. I'm going to do it the other way. All right, so I have a V squared, and I have a 24, and I'm going to split. It's the same thing, you guys. It's just one more line of work, okay? And I have 10V, and I'm going to split it into two things. So what two things can I split it into that's going to make 24? 6 and 4. So plus 6V plus 4V. So it's just one more step. So I've got this, which I'm going to factor V out of, which is V plus 6. And then I'm going to have this, which I'm going to factor a 4 out of, V plus 6. Now they match the V plus 6's. So I have V plus 6, and what's left over that's not in parentheses, V plus 4. I want to check to make sure I'm right. This is 6V. This is 4V, which makes 10V. And V is V squared, and 6 and 4 is 24. So I know I did this correctly. I'm going to go back up. I know. What I'm trying to do, you guys, you shouldn't be trying to constantly copy and look and copy and look. I'm trying to go fast enough so you can just watch me do it really quick and like really take in what I'm verbally saying in my head. And then you can copy it down real quick. Okay? Do number 8. We'll give everybody a chance to write this one down. This one, which one? That's what we're trying to get. This is what we wanted. This is your answer. This is your check. This is your check. Because you're like, we just undid what we did. We're checking it. Got it? Okay, yes. Thanks. Would it be 5V or 2V? No. Because 5 and 2 make 7. Right? 5 and 2 make 7. Yes. this is your answer. This is your check. Because 5 and 5, you can't just do 5 and 5 because 5 times 5 is 25, not 24. That's exactly why. You get it? So you're splitting this number up so you can split it to add to the 10b, but when you multiply 6 times 4, you get 24. So that's what you're looking for. You're looking for two numbers that add up to the middle number, but multiply to the last number. You got it? What? For number 5. Hold on, let me go to it. Number 5. Good. You do not distribute it. Good question. Check this out, guys. On number 5 on your homework, there's a negative sign in front of it. Aaron? There's a negative sign in front of number 5. So all I know about this is that I've got an x, I've got a 0 at -1, and I've got a 0 at 6. So -1, 1, 2, 3, 4, 5, 6. So there's my zeros. I know that now I'm gonna leave the negative alone. Leave it out here. And what I'm going to do is I'm going to go ahead and do what I've been doing. X times x is x squared. 1 times -6 is -6. 1x minus 6x is -5x. Right? I don't have a lot of room on this. You got it? 1x minus 6x. 1x minus 6x makes -5x. This is -5x, but we're not done because now we distribute the negative. So now it's going to become -x squared plus 5x plus 6. It changes the y-intercept, and that's going to make sense because it's pointing down. So since we go up 1, 2, 3, 4, 5, 6, that makes sense because that's going to make this arc like this. It wouldn't have made sense if it was down here, right, Kane? Because it has to, since it has a negative in front of it, it's a negative function. Exactly. So my axis of symmetry, I can't really tell because this graph is so small. 1, 2, 1, 2, 1, 1, 1, 1. I think it's right here. It looks like, can you guys tell me, is it x equals 2? Is that my axis of symmetry? Can you guys count? Your graphs are easier to see than mine. Aaron, you're gonna burn out that marker. So then we've got, is it 3.5? Is it 3.5? Thank you. Are you sure it's 3.5? Or is it 1.5? What? I do. Let me count on the paper. So it's positive 2.5. It's 2.5. 2.5. And then we graph it. Oh, that is a horrible, horrible graph. Okay, so you guys, for Kaylee's sake, because she's going to be gone, you have to remind me to record every day, okay? All right, what do you guys want me to do now? Yes. Axis of symmetry by counting. The axis of symmetry is exactly what it's the axis of what makes it symmetric. So if I've got points here, I just start counting in until I find the middle. How did I know where to go up and down? This is my axis. This is my y-intercept right here, right? So since this is my y-intercept, that has to be a point on my graph. And since that axis of symmetry is exactly what it means, it's like the other side has to be exactly the same. That's how I got the other point right there. And then the fact there's nothing else guiding my graph other than the fact that it's a negative function. So that means it has to be pointing down. So those are the only 3 things that you're using. You're using, probably more than 3. Let's count them. 1 is your zeros. 2 is your axis of symmetry, which we find in between the zeros. 3 is your y-intercept. Then the symmetry with the y-intercept, there's 4. And then 5th, whether it's a positive function, we go like this, or a negative function goes down. Okay? So you're using 5 things to guide you. Yes, Kane? Number 6 would definitely be the difference of squares. The difference of squares pointing down. Check this out, guys. Since it's the difference of squares, I already know that 3x and negative 3x are going to cancel each other out, right? The difference of squares, they cancel each other out. So it's just x squared minus 9. See how this is a square, x squared, and 3 squared is a square? So you know you have 2 squares with the difference. That's why they call it the difference of squares, because it's got the difference in between them, right, Joey? Now all I have to do is apply a negative to it, because there's a negative out in front of this function. So it's negative x squared plus 9, and a negative x squared plus 9 gives me zeros at x equals negative 3 and x equals positive 3. So 1, 2, 3, 1, 2, 3. Axis of symmetry is right in the middle of them, which is at x equals 0. That wasn't very pretty. X equals 0. My y-intercept is that constant, which is positive 9. 0, 9. So up here. And Christiana, now back. Christiana. So this one, actually, I don't even have any more pieces of information. That's all I can do, right? Negative, what's making it go down? Anybody need help with some of these factoring ones? Number 8. Let's do number 8. I'm going to copy it. And we're going to check our answer. Number 8, I've got s squared, and I've got negative 40. Can you think of 2 numbers that we can break 3 into, but when we multiply them, they make 40? Well, let's start with 40. 4 times 10, does 4 times 10 work? You can't subtract 4 and 10, right? What about 8 and 5? Barry? 8 and 5? Would 8 and 5 work? 8 and 5 is 40. Does 8 and 5 make negative 3 somehow? It does. So I've got an 8s and a 5s. We just got to figure out which one's positive and which one's negative. 8 is negative because this is negative, right? So it's negative, positive. All right, so now I'm going to factor here. Factor out an s, and I get s minus 8. And over here, I'm going to factor out a 5, and I get s minus 8. And I say, bingo, I know I did it right because I've got something that matches. So I'm going to factor s minus 8. What's left over if I take the s minus 8 away? S plus 5. There's your answer. Now we're going to check it. You're always breaking it down and then factoring. So this is negative 8s. This is positive 5s, which makes 3s. This negative 8 times 5 is negative 40, and s times s is s squared. So we double checked, and it matches, and we did it right. We checked it. I want to see checks on all of these guys, because the checks are going to make you stronger at factoring, believe it or not. Multiplying it out is the inverse of factoring it, right? Yes?
So for number 9, what would be a minus 4?
Number 9. I'll put it back. You get a minus 4, a minus 4. Or you could write it. It's going to be skimming the x-axis. It's a double root. Got it? Here, I'll go back, guys. There you go. How are you guys feeling? Okay, guys, you've got a quiz next Wednesday on this. Okay? So we're going to do, it's not going to be a group quiz. So listen up. So Monday and Tuesday. So this, Monday and Tuesday, and then you've got a quiz. So don't not do your homework, okay? Because if you don't do your homework, you're going to be lost on Monday. We're going to be lost. If you're lost today, what should you do? You could watch my video on YouTube, or You could watch my video on YouTube, or you could come after school. I bet you I could clear it up in about 10 minutes after school. Okay? I know it's Friday, but I'll stay if you guys are willing to stay. Have a great weekend. Done.